Hello, everybody, and welcome to another wonderful webinar, phoenixNAP and HPE together. Today, we're going to be talking about the power of composable infrastructure, specifically Intel Xeon 6 and HPE Gen 12. I've got my great friend Peter Groth with us. Welcome, Peter.
Thank you very much, Will. Great to see you again, buddy.
Absolutely, absolutely. So we're gonna kick right into it. We got a lot of content today. We're gonna start real quick with a couple poll questions. So we'll shift over to that. And my lovely friend Martina is gonna start that poll question. If you could do your best to tell us, where do you currently host your workloads? I know it's gonna be a mix for the most of everybody, but I'd love to understand where everybody's putting their stuff today, and we'll talk about kind of our opinion and where things go with that. I'm going to give it a second. This is a new GoToWebinar version, so I know everybody's not super familiar with it.
It's pretty slick,
Um,
though, I will say.
it's not bad. I'm actually liking it. I
Mm,
think I like it better than
mm.
the old one. Nothing to install, which was nice. So that's really
Yeah,
good.
always, right?
Yeah, GoToWebinar, install it every time. It's stupid. I mean, okay. I think this kind of is representative. I don't think it shows us the results on screen like the old one did, but roughly 50% on-prem data center. I assume most of you mean co-location, not really on-prem, but we'll go with it for now. 20% only in the public cloud, 10% across different clouds, and then the rest of the lion's share, all of the above. So we will kind of move on. We got one more quick one to do here. What are you dealing with as your biggest IT infrastructure challenge? What kind of keeps you up at night? And let us know kind of where you think I have my own opinions on this, Peter, in terms of where people's current IT challenges are. Um, and yeah, I think what we see, and we'll see when the poll comes out, what we see on our side is really two things mostly: cost, right? So people are just really hyper focused on controlling costs. Um, I think if you're all in public cloud, what we see a lot is vendor lock-in being a challenge, right? If you chose to go all in, or that was your mission 5 years ago. But frankly, I'm kind of a little shocked. Overspend was certainly number one. Uh, Poor performance, number two. So that's could be interesting. We're going to talk a lot about performance today, and kind of what Intel, HPE, and phoenixNAP have been able to bring to the market together. And yeah, so we'll kind of go through that and kick it out. So what we're finding, as I just mentioned earlier, was that most people are typically multi-cloud. And when we say
Yep.
multi-cloud, we also lumping in hybrid into that, right? So we're getting co-location plus one public cloud provider, two, two different co-location providers. It's kind of all over the place. Very few people have ultimately ended up in a single cloud provider. While that was a mission for a lot of people to do adoption around AWS or Microsoft Azure and just go all in. The reality is something typically is nagging when it comes to that. It's like, man, it's too expensive to do that. This workload doesn't run as well in that environment. And so organizations that have no on-prem people left, they either were born in the cloud and they choose multi-cloud. They go to a different cloud provider and they find the thing that works. A lot of organizations that had competencies in the data center, I mean, traditional IT, buying server storage network, putting them in the data center, they have chosen to keep some of their stuff behind, right? Even if they were had a mission to kind of get there. Right now, what we're seeing is that some type of of challenge or new mission, AI dominating these workloads, is driving people to find new solutions for IT infrastructure. They are, as the data kind of shows here, looking at ways to integrate AI into their, workflow. For a lot of people, this is starting with um, kind of post-trained knowledge base, right? Support
Yep.
chats, things like this. We see a lot of that. A lot of folks are using it to do better reporting, enhanced reporting, deeper dives into their data than they've ever done before so that they understand their business better. Um, we still see a lot of people trying to at least augment with public cloud, right? The journey that I think it was it Werner Vogels or something like that said, no, in 7 to 10 years, everybody's going to be in public cloud, right? We're still
Yeah, that
seeing,
was fun.
yeah, we're 15 years essentially into this, and people are still looking at public cloud adoption, right? Trying to find what will work or what won't work. And funny enough, we're seeing almost as many people trying to find things to get out of public cloud because it doesn't always work the way that you expected it to. Some applications suffer from performance challenges. Sometimes it's too costly, and there's lots of things that go around that. But generally, the demand for computational resources only continues to climb, right? And it's stressing the crap out of a lot of people's systems. We saw that in poor performance on that survey, I think. Um, so this is our opinion, right? This is the PNAP opinion on what you should be looking at to kind of make sure that you're running full force towards your company goals, right? Not IT goals, actual company goals, right? You got to get your infrastructure in a place where you're meeting the performance needs of your business. You have to find ways to integrate new technology as efficiently as possible into that platform that you're building or you're augmenting, because you have to find ways to adopt some of these capabilities that do sound on the surface like fads, but they're truly important. And if you find yourself too far behind the eight ball, you're going to lose competitive advantage from a business perspective, and maybe look bad from an IT leadership perspective. Increasingly, efficiencies through automation are driving a lot of things, right? This is being helped a lot by LLMs and AI, right? What used to take days, months, weeks, whatever, to build even minorly complicated automation with Terraform, Ansible, and other things can be stamped out in hours now, right?
Yeah.
Hours meaning instantly, and then a ton of customization and QA to make sure it's not ridiculous, right? You're not having to take the full brunt of that workload anymore. So automation is becoming super important. And then I, with everything that we've talked about so far, rising costs everywhere. Clearly, inflation has been well above, kind of your standard 2.5, 3% for a while now. Tariffs are creating challenges for our OEM partners, like Peter here on the call. But
Just a
those
little bit.
byproducts,
It's an interesting environment to operate in for sure. That's
absolutely. And you find yourself, ultimately those costs have to be passed on to the consumer for the most part, right? So,
yeah.
these are things that if you're not dealing with them yet, you will deal with them in the future. So, hopefully not to the level of what we've seen so far, but into a place that maybe at least is manageable. So with that, I'm going to pass over to Peter. He's going to talk about HPE Gen 12, what HPE's outlook is for the future in terms of infrastructure. And then I'm going to come back to talk a little bit more about how we're working together to make everything better.
Thanks, Bill. I mean, I really appreciate it. I really like the way that you set the stage on this. I mean, the world is really at a little bit of a crossroads when it comes to compute resources in and of themselves, right? If we step back a little bit and look at how the world has traditionally worked, it's been an environment where we've not had, inflationary pressures as you were talking about, right? We've had a pretty stable technology roadmap as well that has, allowed people to sort of kind of like gradually run their infrastructures out to their logical conclusion, but with a lot of the accelerators that we're seeing coming in, obviously the architectures themselves are changing. On top of that, as you were touching on, there's a couple of forces that we really haven't seen that much of, up till in the last probably 12, 18 months, right? Inflationary pressures being one, cost of capital is the other, right? And going and actually financing your stuff yourself, right? I mean, anyone who's tried to buy a house, within the last, year and a half, it's like, the mortgage rates are eye-wateringly high, right? Same thing goes for power. It ain't getting any cheaper. And, with the advent of AI and with, and it's really not, I don't want to say the advent of AI, right? Because I mean, let's just dispel that for a second. AI is many things. And, if you think about AI from a, simple production standpoint, in a manufacturing facility, we've had AI for 20 years, right? These are the little cameras that take pictures of all the stuff that gets produced to basically figure out, did we produce the right thing or is there flaws in it? But in terms of the generative AI, that has put an enormous strain on the power resources, which is really becoming very rapidly the scaling factor, right? I remember back to when I started as a product manager, back when the earth was still young. When if we walked into a data center that had 8.6 kilowatts for rack, they were well provisioned, right? Right now the design point for racks, that use AI is basically a megawatt, right? That's what we're building to right now. Our shipping infrastructure for those sort of things is basically set at a 400 kilowatt per rack kind of level, and obviously that's putting a lot of strain on how the systems operate. But it also means that you have to be pretty frugal. And so what it comes down to is essentially comes down to ever more trying to balance the cost of standardization with the with the upside that you get from customization, right? And so if you think about how a traditional set of compute environments have been built, is like this is what you see on your left hand side here, right? These are basically rack and stack pizza boxes. They come with a series of preset features in them. And sure, there is a lot of different models, there's a lot of different variations of things, but what they basically are they're independent stamps of functionality that's pretty monolithic in the way that they're built. And so that means that you have to make a trade-off at this point in time about, do I want these features or not? And if I don't want them and I don't want to pay for them, not just in terms of procurement, but also in terms of actually powering them and maintaining them, then I have to make a trade-off. Do I want 10 different server models with all the complications of operations that goes towards that? Or do I rather want to just, close my eyes and ignore that I am, you know, under optimized or not fully optimized, and that I have, things in my data center that frankly is burning power and requiring uptime that, I just don't need, I don't use. So this has always been sort of kind of like an eternal struggle. I remember back like 15 years ago, 20 years ago almost now, right? Which is, when we started coming out with some of these composable infrastructures in the very first place, and the modularity in those, where you could essentially mix and match, was ultimately instantiated in what today is known as blade systems, right? I mean, it's blade servers, right? It's like, hey, here's one compute brick, here's a different compute brick, but we're removing all the I/O complex out so that you can at least like vary that. We couldn't really fit in storage, so storage had to then become arbitrated, typically fiber channel back then. Today NVMe over Fabric, but the reality is that while it was modular, it wasn't really granular enough to make sense. So what we did from an HPE standpoint, and what I tasked my team to go and do in my capacity as chief technology officer, was to basically go out and not just work within HPE, but work across the industry to see if there was a way by which we could come up with a much more kind of like modular approach to these things. And this is sort of kind of like what you see here. Monolithic architectures are essentially an instantiation of a product manager somewhere, whether it's inside of HPE, whether it's inside Supermicro, Lenovo, Dell, any of my colleagues and competitors in the market. We sent them out into the server making kitchen, quote unquote, and then they pull down X number of power, X number of PCI lanes, They put in some BMC, some CPU, some memory, this and that and the other, and then they instantiate that as a server. And while that is useful, it also means that if you're going to try to optimize that, you're going to have an enormous amount of different combinations of that. I fully reject that kind of like idea and went into OCP, which is, one of the standardization bodies out there, and frankly got, engaged with what for a vendor like me would be kind of like strange bedfellows, right? It was, the Dells of the world. It was, you guys from PNAP are on one of our advisory boards for it. Um, Google was in there, Meta was in there, tons of other customers, a couple of other vendors. And what we fundamentally came up with was a way to basically take these servers and decompose them almost, right? And basically bring them into small logical chunks that were to some extent self-contained, but would not be able to live by themselves. They would only be able to live in the combination of components. And then ensuring that those components basically, both from an electrical standpoint in terms of connectors and what have you not, basically click together, but more importantly, that all the firmware and all the software that goes into these things are basically intelligent enough to self-assemble along the way. And so the outcome of that is a couple of things. The first one is you can now go and you can build yourself a server environment that's fully optimized specifically for your use case. This is something that the very large kind of like superscalers and hyperscalers out there have been doing for, a decade, but they've been able to do it because the volume that they take. And hence they could go out and say, well, we want this very specific motherboard only to run this very, very specific workload. And then because they were buying, a few 100,000 of them, they could make that work. For the rest of us are mere mortals, right? That's not a model that we can do because now it starts, as I was telling you before, to basically weigh off on, okay, well, if I have 50 models in my data center, now I'm going to basically have to set up a, care and feeding schedule for each of them. So the first thing here is the reuse of the models or the modules that you see inside of the architecture that essentially ensures that as you combine them, you're still getting enough volume of the individual components to basically make sure that you get a decent price on the procurement part of it. But the other half here is all the software and firmware integration essentially allows you to see that whole thing in the data center as just a single server because it's all running on the exact same firmware base. And so what you're essentially getting is that you're getting relief from the complexity of the operations while still being able to optimize your shapes and sizes for what your specific workload is. So it's essentially a way to mimic what it is that the hyperscalers are doing, but doing it at a scale that is much more practical for us normal people. And then, you can say as an added third benefit of this, as that ecosystem now grows, because everything is intercompatible, that means that vendors don't necessarily have to be their own IP factories at all times, right? You could, and I know you've already seen that in some of the offers that we're doing with you. If there's a need to go and get a part that we don't have, we
Yeah.
can source that in the industry, we can put it together, and it quote unquote just works. And that's really a revelation because it sort of kind of like democratizes the access to the way that the big cloud players are basically building their infrastructure. So in short, this is what we call DCMHS. Welcome to OCP. They love their little abbreviations. It stands for Data Center Modular Hardware System. And this is, for anyone who's been out looking at any of the hardware shows lately, you go into an Intel booth, you go into an AMD booth, you go into my booth, you go into Supermicro's booth, you go into any of them, and this is the way that hardware is going to be built. Think of it almost as Lego bricks going forward, and it's kind of like a brave new future because it's both very scary from as an OEM to basically have to open the door to all my competitors, yet at the same time it's extremely liberating because it allows me to go out and actually innovate on the customer angle on this of basically saying, well, how do I actually build you something that's more optimized than the next guy, and how do I make sure that the experience is where it needs to be.
And one of the downsides of the doing it the way even the big guys were doing it, where they're buying 100,000, customizing a crap out of it, is that they were kind of stuck with that vendor. Like that was a commitment to that vendor.
Oh
And
yeah,
so I look at it as opening up the doors in both directions, right? You're able to go look at business that maybe you couldn't tap into in the past because you didn't have that customized thing for them.
absolutely. And frankly, it makes it makes for a very interesting kind of like way to basically differentiate between vendors because let's be very fair. It's not like me or any of my competitors in the industry. It's not like we build processors, right? It's not like we build
Right.
memory. It's not like we build hard drives, right? All that comes from industry commodities. So, what the secret sauce here is and what actually makes the difference is the innovation that you can put in elsewhere in the system. So this becomes things like manageability, control plane, ease of updates, and then obviously, things like security. And this means that the individual vendors are now competing on merits of, innovation and actual implementation and experience instead of, who can get to the lowest price. Because at the end of the day, you look at some of the components that we put in there, specifically in around our management plane, how much is, quantum safe encryption actually worth to you in your security domain? Well, it should be
Yeah.
worth quite a bit if you actually, if security is something you worry about. And this now becomes a de facto decider of which vendor you typically choose to go with, but it does not necessarily have to limit you because of the industry interoperability. It does not have to basically limit you in your choices of what functionality you wish to pack into your shapes.
So what does this look like for customers now? What's on the truck?
So what's on the truck right now? I mean, it's one of those like I took a look at along with the product with all our product folks, people like yourself, a lot of our customers had a lot of input on this. As a matter of fact, I would say like probably 50-70% of the portfolio is direct customer designs. I mean, I know that you and Igor on your team basically sat in for, you know, countless and
Many
countless
sessions.
countless sessions
Many
on
sessions.
this is like, would you like this or would you like that, right? And
Yeah.
that's sort of kind of like my commitment to our customers is to make sure that we listen very intently, right? I mean, we can go off in an ivory tower and make decisions, but at the end of the day, if those decisions are wrong, then it serves no one. So one
Right.
of the first things that we were listening to was, where should we start? Should we start in two socket servers? Should we start in one socket servers? Should we start with, high power? Should we start with efficiency? Where should we go? And so what it looks like and what it came out to was essentially these two models here, which are our one socket Intel Xeon 6 based. Started out with Share Forest, so basically the E-core based product, simply because efficiency was very very high on the list. Plus the fact that Intel just produced a superior product at the time. I mean, it was really really good. And what you're seeing here is that you're essentially seeing two, from a operation standpoint, identical servers. Sure, they're packaged differently, and the modules, which includes things like chassis, I/O front and back planes, cooling methodologies, all those sort of things, are basically shared between them. And then you have the opportunity to basically mix and match the componentry, put it together. Now, as you see them here, they're instantiated, and you will see they're called the DL320 and the DL340. And marketing will tell me that, oh, brand compliance, oh, HPE ProLiant Compute DL320 Gen 12. But for short, we call them the 320 and the 340. And those are sort of kind of like the public facing versions that you will see, right? These are, you can almost think of them as the preset mixes that we've done out of the different subcomponents that we have, but these environments are fully reconfigurable. It
I like to think of them
literally,
as just sheet metal, right? Like those
right,
those two
it's
building blocks are just sheet metal, and then inside
exactly
that
right.
thing Could be
Yeah,
anything, right?
then it becomes, then it becomes a arbitration through, 10 different cable kits, right? And that basically decides whether you have like two hard drives or whether you have 24, and the slots are all, 100% standardized, right? So you can snap, things out, put them somewhere else in the server if it is such that it doesn't fit where you want it to be. They turn around, quote unquote, right? So if you want all your IO on the front, you can have that as well. It's just a different wrapping of sheet metal. The beautiful
Yep.
thing is that once you start rattling off that list and you actually look at how many different, shapes you can make, out of the just the componentry we have here, we make about 80 different kind of like, servers or server shapes, and all of them runs on the exact same firmware stack. All of them runs on the exact same management stack. All of them instruments exactly the same way. So what you now really truly have is the opportunity to go in and drive that operational flexibility while you basically right size your infrastructure for the for the workload that you're running. And in terms of, deployment, it looks the same, right?
Right.
It's like, yeah, they'll show up with slightly different names, but if you squint your eyes and say, okay, well, so 320, 340, same thing. Once you interrogate it and ask it, what capabilities do you have, it's all the same. And the trick here is that drives an investment protection as well, because each and every one of the components are basically individually upgradable. So should you decide at some point to basically say, well, you know what, I want this with P cores instead. I want
Hmm.
this with the Grand Rapids stuff in it. And, in this case, it's simple because you essentially just have to swap the processor. But, if you don't want to be one of the ones that, end up on the wall of shame for having bent one of the pins, one of the countless pins on these CPUs, what most people do is that they go out and they buy a new CPU board. But, CPU and memory boards are now separate from the rest of the motherboard and the rest of the logic there. So you literally unclip, like, I think it's four cables, and you undo five screws, and then you plop in a different thing, and you are back up and
Yeah.
running. And there is no change to your firmware. There's no change to your setup because the personality is actually kept in the management and control plane, not in the CPU boards anymore.
Super helpful for people like us that are automating lots of infrastructure
Oh
globally.
yeah,
So
oh yeah.
how does this like break down in terms of, you were on a mission to do something different. You've kind of got here with this first release. Tell us, really kind of your North Star in terms of what you're going towards with the next Gen 12
Yeah,
release.
I mean, it's a great question, right? Because I mean, my North Star is fundamentally, and it's funny how, everyone comes full circle, in their careers, right? I started out as a customer services rep, and so back then my North Star was basically to make sure that, the customer had what they need. And then I went into product, and, then my North Star became technology, and now it's essentially back to, well, how do I basically take that technology and bring it into a customer environment where they can trust their business on our equipment, right? Because that's fundamentally what it comes down to. At the end of the day, there's nothing inside of our daily lives, in, neither in private nor in our work environment, that can essentially be accomplished without the use of IT, right? I mean, we can't place a phone call. I'm sure we can reintroduce pen and paper in the office, but it's not terribly efficient, right? So the reality is being able to bring IT to people and bring the capabilities to our customers that allow them to tailor the infrastructure to their needs, understanding that what used to be acceptable levels of waste, whether it was from a capital intensity, whether it was from a power usage or from an operational time usage, those things are just not on the table anymore, right? Then the second thing is about trust, right? I mean, we all sit and we look at the world affairs around us, right? And it certainly is a little bit more of a complicated space than it was even just, a couple of years ago. And so being able to secure it, being able to protect, and being able to put those things together is what it comes down to, right? And so fundamentally, it's about establishing control planes, having things basically provisioned at the speed of cloud, being uncompromised about it, right? I mean, security is very simple. It's about the weakest link in the chain. And so at the end of the day, that means anything from when the chips are made, how they're actually moved through the supply chain, how they are put together, who puts them together, how's firmware loaded, how are they actually installed, eventually in your data center, and how do you then take that chain of custody and basically bring it forth. So as you deliver things as phoenixNAP, that environment is secure and it's protected. And
And
that's
that
fundamentally what it comes down to.
100%. And I think, when we look at this last slide, this has been the thing that's made the most difference to us, right? Getting this kind of unified experience for deployment, right? When we're talking in scale of tens of thousands of servers globally, right? You have to be able to handle this stuff in a,
Yeah, I
controlled
mean,
fashion.
the days of running around with a USB stick to patch stuff, I mean, they're long gone, right? I
Way long
mean,
gone.
yeah, I mean, always fondly remember, my first walk into your data center where, I was going like, so what's your repair process? And you're like, well, we got this process we call bring out your dead. If it doesn't work, we'll pull it out and we'll plop another one in, right?
Exactly.
And then the automation system has to take over because we don't have, 25 Smurfs to run around and basically install these things with USB keys anymore, right? And so
Right.
that really comes down to, how is the environment programmable? How is it, and in a word, how is the infrastructure actually composable so that you can, compose, decompose, and recompose and have that done in a programmatic way where your environment and the time that it takes out of your production cycle is not sacrificed.
Agreed. Agreed. 100%. So awesome, Peter. Thank you so much for taking us through
Thank
HPE
you.
Gen
Thanks for
12.
having me.
I'm going to talk a little bit more about what we're doing together. For a lot of you guys that may not know us, maybe you got here through HPE, you don't know who we are. We're a global infrastructure company. We have been delivering both data center operations and infrastructure called server network storage operations for years. About 4 years ago, we decided, hey, look, the next generation data center has to be different. There no longer are people going to be able to just buy everything and stick it in themselves, manage everything themselves. Maybe that's a capital problem, maybe that's a people problem. Hard to tell, but it's a skills issue increasingly, right? Some of us are becoming dinosaurs, and they they're the only people that know how to manage infrastructure. But also, public cloud's not a panacea, right? Like you can't just put everything there. And so we decided, hey, look, people want to have some applications on prem in colo,
Mm,
but that is becoming increasingly difficult. And so if we can deliver an environment where the data center becomes programmable naturally, that is what people want. They don't want the capex burden. They don't want the management overhead. They don't want to break fix servers all day long. They want to work on critical applications that make sense to their business, that transform their business. They may not be able to do that themselves though. So they need another option. So what started, and it's currently so called bare metal cloud, the idea was, what if we could give you a data center like experience where you have your own dedicated servers with
mm.
all the freedom to run whatever operating system you want, whether that's VMware, Hyper-V, Nutanix, Ubuntu, you name it, right? The ability to do that, but have it be provisioned instantly. To be able to click a button and say, look, I need this server, this much storage, these 15 networks, VLANs, right? Go. And have it be provisioned in an automated fashion, whether that's you clicking a button, and I'll show you that live here at the end, or that's you executing a Terraform script and everything just instantiating the way that you want it to instantiate, right? So we've put so much time and effort in tandem with our partners at HPE to build out an environment that is literally 100% automated, right? We have failed you if we cannot deliver you the data center experience that you need. Sometimes we have to go run a cable. Like there's a physical thing that has to happen there. We're working on that. We're working on trying to make sure that the access to your MPLS environment can also be instantly available, right? So that's kind of our North Star. That's what we're working on. We've been pushing this to market now with these kind of set of features in mind. We want to provide cutting edge technologies, latest, greatest CPUs, right? We were the first people in the world to launch the HPE version of the Intel Xeon 6 Sierra Forest or efficiency core version. We will be probably, I think, Peter, the first people to bring Granite Rapids to production
Yes,
on
sir.
that platform. And while not having to deal with some of the burdens of public cloud, the cost of the hidden cost that people don't understand that exists in the core components of public cloud, where your EC2s, your EBSs, your Azure VMs, Google Compute, those things are burdened by the other 190 platform services that you don't use, right? If you just want infrastructure, it becomes a very costly way to consume it, right? If you have a traditional application that is going to be up and rolling 24/7, 365, established demand patterns, and even if not established demand patterns, we offer hourly too, so you can go up and down. But yeah, like you need to be able to consume infrastructure as a service, not platform as a service that comes with tons of lock-in. But you need to be able to do it in a cloud modality, right? To be able to provision instantly, stand up, tear down, augment with the latest and greatest application sets, whether that's Kubernetes or some next generation. I mean, I thought it was just going to be like containers on top of servers, but now apparently we're talking about virtual machines on top of containers on top of servers. So, but whatever you choose to do, right? We are trying to build that next generation data center reality for you. And so,
Yeah, and actually,
yeah,
I think, if I just cut in here for a sec, right? I mean, this becomes even more acute as you start thinking about, how does that actually instantiate in a world of AI, right? I mean, as you were saying in your opening, right, the world is still training LLMs and, but we're rapidly getting to a point where we're beginning to consume them instead. And
yes,
that fundamentally has to be instantiated as some level of an agentic AI, environment, and being able to spin those things up in the right location on the right infrastructure sizes,
yep,
that's going to be what makes or breaks the ROI on the vast majority of these deployments.
100%. I think if what people will realize long term is that there will be so much consumption of uh, AI that from an inference perspective, that um, the only cost effective option at scale for scale out businesses will be to have these agents, right,
Mhm.
that are doing predictable tasks with predictable types of workload requirements, running the same way you run a virtual machine today for your off the shelf application that you built 10 years ago. If you try to do that by talking to an API or leveraging someone's agent as a service model, you will end up paying a lot more and you will have a lot of features you don't use, right?
Yeah, and,
Are
and
we
plus the
there yet?
fact you have to use the plus the fact you have to use their API. And
Yeah,
let's face it, right? On an API level today, API integration is, as much of a vendor lock-in as choosing a logo on the front of your hardware, right? For those
or
who have
more.
been for yeah, because I mean, for those who have been unfortunate enough to develop their entire automation framework in and around, say, for example, the AWS API. I mean, congratulations, you might as well have bought yourself an AS400, right? Because it's just as proprietary, right? And it doesn't work
Yeah.
anywhere else.
That's it. That's 100% it. So I'm gonna show you this. I'm not gonna belabor the slide because we're gonna look at it here in a second. But it is about getting these objects, these shapes, as Peter calls them, up as fast as possible. Our friends at Chuckstack, they took these HP Xeon 6 servers right off the bat. They said, "Hey, look, we've got these interesting workloads for our customers. They're a consultant." And we need to find ways to scale out our workload across many CPU cores horizontally in order to get the most efficient outcome for our customers and the applications, right? And at the end of the day, for them, it was about saving them money so that they can be better, they can be more cost effective for their customers. And the power of Xeon 6 in terms of scale out core architecture on the efficiency side, and then what we'll talk about, kind of at the end here with Granite Rapids on the performance side, is pretty intriguing, right? We're finally, as much as the stock market kind of hates it, I think, Intel's kind of back, right, in terms of at least on the roadmap, and we see that on the client side already, right? Like we're already seeing that with AT Angstrom on the client side, which is
Hmm.
going crazy right now with their the new CPUs that they just launched. Um, all that technology is coming fast and furious to the data center world, right? So it's going to be a super interesting future, right? Between that, but what I can say confidently in all of this is, you know, HPE, PNAP, everybody is attaching uh, the whole cart to the horse of whoever can help the customer the most. For a little while, that's been
Absolutely.
AMD. For right now, it's going to be both. It's going to be Nvidia, right? We're going to see tons of things coming forward with that. But we're here just to get the right applications in the people in the right hands of the people that need
Yeah,
them.
and I think you touch on a very, very key point here, right? Because while we're talking about Intel 6, Intel Xeon 6 here, right? The power there is in the composable platforms is that if you find out halfway through your life cycle that you actually need, say, NVIDIA, or you need, Ampere, ARM, if you need, AMD instead of your Intel, or, vice versa,
Right.
then again, the ability to have a modular infrastructure where it's not, okay, let me take this whole thing out of the rack and chuck it in the bin, which, you know, environmentally is not the most sound thing to do, either, right? There's a huge carbon footprint that goes with these from a sustainability standpoint. And being able to upgrade each and every one of these piecemeal, I mean, literally vendor shifts, of
Yep.
your CPU provider, that's very much there for the taking.
Oh, I'm excited about that. We're not quite there yet, but oh man, I want to be able to just rip out that host processor module and put a AMD chip in, and then rip it out again a year later and put the Intel chip in. We're almost there, but I think that I think we could see that here in the swift future. But I'm gonna jump into a quick demo, just so you guys can kind of see what this looks like. I believe I will need to re-sign in here because I let it expire. So bear with me. Took too long. Oh, my computer has decided that it does not like me anymore. And we are going to. That's how this works, in fact. I'm going to go ahead here. All right, here we go. So once you get logged in, we have tons of options we're not going to be able to get through today. But let me just show you how quick and easy it is to deploy a dedicated piece of infrastructure on virtual networks as complex as you want to make them with the operating system of your choice. It's super simple, right? So once you click deploy a server, choose your location, you choose the type of commitment. These are dedicated instances, full computers dedicated to you, available hourly or with any type of term commitment for discounting. You go down here, we click. I love my discounts, the most amazing discount on earth. But as you can see, at a dollar
Is it
72 an
free?
hour, yeah, at a dollar 72 an hour for 96 physical cores, 256 gigs of RAM, 4 terabytes of onboard NVMe, and 50 gigs of network. That would be really hard to beat in a public cloud environment. Go check out some of those metal boxes that they have in AWS and Google, and see how much those cost. So we're going to go down. We're going to choose our operating system. Tons of options here. We do provide if you standardize on Ubuntu, we provide those pre-provisioned or lightly pre-provisioned so that they can be stood up quickly. I'm going to go ahead and just give it a name here. You can choose whether you want us to raid the 2 disks that are on there. So if you just plan on using it as as a mirrored drive. In this case, it'd be RAID 0 or RAID 1. You can customize your root partition, put the SSH keys that you want to use to access it. Tons of customization here around Cloud Init that we can't get into on this demo because it's really short. That you can do pretty much anything, including more complicated versions of all the things above there. Um, a lot of networking capabilities. We spend a lot of time trying to make sure that the platform replicates enterprise networks the same way that you would deploy them. We want to make sure that we're not standing in your way. The way that you deployed your VMware environment in your data center 5 years ago, we want you to be able to deploy it the exact same way on our infrastructure. We offer kind of this, go ahead and just get a public IP assigned to a box. Most of our enterprise customers don't do that. They create complex private networks. They, have router infrastructure that they put in place, and they kind of build all that stuff out. For the purposes of this, we're just going to go ahead and deploy it. And that server that we just clicked on will be ready to actually access somewhere between 60 and 120 seconds, right? So all that horsepower on demand, fully customizable networks, network attached storage powered by our buddies at Vast, who both HPE and phoenixNAP are heavily in partner with, and the true enterprise scalability that you're looking for, deployed like it's public cloud, consumed like it's public cloud. That's really the message. Data center 2.0. That's what we're pushing forward. And that, that's kind of our mission. So I'm going to go ahead and go back to our thing in the interest of time here in terms of our presentation. Second here. All right. All right. So we're going to go on to Q&A. Let's see if we've got some Q&A here in the things. All right. So first questions we got from Paul says, what kinds of unique efficiency gains can enterprises achieve by adopting a pay-as-you-go model for composable infrastructure? I think that it's truly about adopting a mix of committed, so everything purchased, if you have the wherewithal to do that, consumed, committed infrastructure, and pay-as-you-go infrastructure for augmentation, right? That's what our largest customers are doing, right? They're even the ones that were born in the cloud that don't have on-prem anymore. They don't have a data center. They don't have any colo. They don't buy any gear. Even those guys, they deploy things on demand. They convert their on-demand instances into reservations as they are sure or have assurance internally that that's going to be necessary for a while. And they commit to that infrastructure to save money. And then they augment when they need more capacity with on-demand consumption, right? And go ahead, Peter. Yeah, jump in on
Yeah,
that.
no, this is really at the core of the conversation about why does this model work, right? Because the idea with composable infrastructure is, and especially when you put it in as pay-as-you-go model, is the ability
Right.
to basically jump from shape to shape depending on what it is that you're currently doing. Right, standing these things up, and I've seen this firsthand. Right, standing up one of these things literally takes like 3 minutes, right? And
Yeah.
so that means that if you have a granularity in the future about, I'm going to need these and these and these things in a programmatic way, if you have 30 minutes, which is, in IT is an eternity, right? You have the ability to basically jump back and forth. A little bit more of a practical kind of like thing for this is for anyone who has a suite of applications that they run, whether it's in their financial environment, whether it's in their business processing environment, what have you, these apps, they change over time, right? That's the whole point about having new updates of apps. And you put that on a traditional piece of infrastructure that never changes, then you're sort of kind of living in the house that you built for until you're done depreciating that server. The pay-as-you-go model gives you flex capacity, as in bursting capacity, but the composability of it gives you the ability to actually go in and update and adapt your infrastructure as your app stack basically evolves.
And people tier their apps. Well, that's another thing we
Absolutely.
see a lot of. It's like they've got a core set of apps that just need performance. The moment that the new generation is out, we see them provision, like migrate, shut down, and then they take the previous gen, or even if they don't shut it down, they'll shut it down to clean it, because we wipe and secure wipe everything. They'll deprovision it to let go of it to clean it, and then they'll take the third tier app and they'll move it on to the
Yep.
thing they just vacated, and they're doing all that without having to like call and wait and ask for more colo space and get new power whips run and all the things that you have to do in a data center environment. Those things take a long time and they ruin efficiency. And so we think it's much better to be able to straddle your applications across. I like to call it right infrastructure for the right application, right? And getting the correct type of infrastructure instead of the one-dimensional environment that Peter was saying people used to do. Get that
Mhm.
right app on that right place.
Yeah,
Um,
and you can say this is a little bit of the magic of, architectures past, like, whether it's HP's Blade system, whether it was the Synergy environment, whether it was, some of the Vertex stuff that Dell brought out, or whether it's, Cisco's UCS, right, which were basically capable of doing a lot of these like complex operations, but at the end of the day, they all suffered from the same thing, which was, they were just too costly because back then the only way you could essentially get to those sort of kind of like intra kind of things was basically to build some very, very bespoke hardware that, gosh, right? I mean, in some cases, I mean, God knows that everyone paid for the flexibility that it gave them. So it wasn't like, they were being taken down the river on the pricing, but it was just really hard to put it together back then. And these days we have technology and we have industry standards in place that essentially allows us to do that, not just in a cost-effective way as a single vendor, but actually do it as a cost-effective way as an industry, because we can now basically borrow the components between different IP blocks.
yeah, and I would also suggest that um, the technology, while containers and things like containers and Kubernetes are not end all be all by any stretch of the imagination, um, the more the more that you can um, um, make your applications agnostic to the piece of hardware
Mm.
that it runs on, the better you can take advantage of some of these options, right? When you're at the efficiency level where you're auto scaling your servers, you're draining servers of containers to upgrade, because that's all you need to do is just like, hey, I need my
Mhm.
app to be on the new gen, right? And you're just auto provisioning next generation systems and putting containers over there and moving it. Like, it can be done. It's done all the time. We watch our customers do it all the time. So I think
Yeah,
that,
and
yeah,
I think the most telling way of basically showing the interdependency here is, you know the Docker command that you typically use to basically create a new container is, as it stands, compose up, right?
yeah,
And it's because what it is that it's composing a software environment. The hardware environments haven't necessarily kept up with that, but that's what's happening now. And wrapped in the right operation model, which is exactly what you guys do on your side, William, with the automation layers, the uniform experience across standing up, all sorts of infrastructure, whether it's compute, storage, networking, whatever. That really helps bring a flexibility that the typical enterprise just doesn't have today. And much of that has been tried to be arbitrated into software platforms like, for example, VMware. But you're paying quite a bit for that sort of kind of like experience and for that insurance policy.
100%. Yeah, that's definitely a challenge for everybody. I should have put top IT challenges. I think Broadcom should have maybe been on the list of top IT challenges in
Yeah,
2026.
that's certainly a unique approach they've taken to their licensing
Yeah.
model. That's for
So
sure.
there was another question about what type of businesses benefit the most from these types of capabilities, right? Um, what I would say is that because we don't do platform as a service together, right? For the most part, and HPE does a
Mm.
little bit more than we do, right? Because we focus on infrastructure specifically, it's very agnostic. It's very generic, right? And is it the right workload? Is it the right platform for infrastructure platform for everyone? No, 100%. If you need every service under the sun provided for you, right? We're not your
Mm.
people because we don't do that stuff, right? If you're just trying to get cost effective infrastructure at the most performance per dollar possible at the, at the highest uptimes available, that's what we focus on every single day, right?
Y-
Yeah.
Yeah, and I would also say, I mean, if you were to pinpoint who specifically benefits the most from this, right? It's either people who have a need to flex,
Yep.
right? And basically see, demand peaks and valleys. And those demand peaks and valleys are not necessarily measured in, like, racks of servers, right? It's typically, need something slightly different. But also for companies that tends to, see change in their app environments, right? Not just in terms of usage, but also in terms of, revving them, and frankly, more, in the future, in and around agentic AI, right? People who will have a need to basically consume ready-made agents, understanding that, you go out and you take a look at GitHub right now in terms of some of the agentic frameworks that are there. I mean, the requirements changes on, a month-to-month basis, and that ain't going to settle down, right? Because that's all driven by, the innovation in infrastructure, and bringing it onto the latest basically gives you a series of advantages, right? I mean, like, William, you guys are exposing, things like, low level instruction sets from Intel and what have you not. A unique feature that you guys do, and frankly, is really differentiating, because it helps take advantage of, as new infrastructure comes in, basically bringing that value straight out to the customer instead of sitting on it and saying, oh yeah, well, no
I mean,
probably
if
really
if you
cares.
if you have ever heard an Intel webinar and they've talked about some fancy feature that's on their chips, these latest and greatest features, I can almost guarantee you they're not exposed through the public cloud, right? Because
Absolutely
why
not.
why would the hyperscaler do that, right? So if you're looking at things like Intel SGX, Intel TDX, QAT, DSA, like any of these capabilities, we expose all of that. We're almost out of time, so I'm gonna jump forward. We're gonna do our last poll question. If you want to hear more about what we've talked about today, um, please go ahead and say yes. We can get some more information in your hands, and help you guys, kind of get to that next level with your infrastructure. I have the winner of the giveaway here from my lovely marketing team. We are going to do that right after this poll ends. In the meantime, I want to thank Peter so much for jumping in here, giving us
Absolutely,
tons of
man.
insights. Thanks, buddy. Always a pleasure talking to you. Okay, we shut that poll down. Thank everybody again. I know this is an hour out of your day. We tried to be efficient with it. We tried to make it impactful, interesting conversation, and we hope you have a great day. Thank you so much.
Thanks, everyone.